Hello, this is Ricky Smith for another Grand Unified Physics lecture. The four greatest physicists in the world are Stephen Gubser, Michio Kaku, Roger Penrose, and Edward Witten, and the fifth being myself. Um, uh, I've already approached Gubser about my ideas. He didn't respond back. I'm going to try Kaku next. Um, With respect to the work I do, I'm most similar to Newton and Tesla, using ingenious ideas to achieve far-reaching results, which would be impossible using the conventional mathematical approach to physics that is so popular today. My theory basically breaks down to four fundamental theories, which are inseparable and in some sense chiral, like rotating around each other. They compose a tetrad of theories, meaning that they are simultaneous, or at least three of them take hold at any particular one time, quantum mechanically, meaning that Heisenberg-wise, three of the theories are in force. One is like an escape clause, which is loosely obeyed. The fifth theory being free space, which is always a given, because you can map that over anything. It's like the null space in linear algebra. The four theories are complete replete theories of their own. There's no way to unify them into one complete expressive theory, but they exist separately. And they are fairly intricate. They're simple in a very elementary way, but they're not nearly as complex as modern mathematical physics is. Indeed, they're barely as technical as the method of images, let alone things like quantum superstrings or something ridiculous like that. People ask about the math-physics dichotomy, meaning that whether or not physics is innately mathematical or math is innately physical, and whether they're inseparable or whether math is just a tool or an invention of the reasoning mind. I would say that the universe is innately mathematical in nature. That's not a given, though. I mean, like, I would say physics is more fundamental than math, but that uh, physics is innately mathematical because it is logical, meaning that the universe makes sense, therefore is mathematical. Obviously, you can't really take things like limits and stuff, but you can say stuff like mathematical induction holds true. That much is true. And I wanted to make reference to things like Bertrand's paradox, Russell's paradox, where you say that the set of all sets is an impossibility because it should include itself, keep adding one more. Therefore, you say that space is infinitely nothing is impossible because you have to keep adding one more thing to itself. Therefore, that logical reasoning leads to the existence of something. I would also like to say that things like the physical universe evolved into a sensible reality because the physics is basically just an arrangement of particles or quantized particles, but it arranged itself in a way when it was created, not created by God, but when it came into existence in a way that was logical, meaning that everything fell into place, almost like you may think it'd be kind of silly that something wouldn't exist until it made sense, but that's really what physics is, and that it became a whole when all the numbers were in sequence, when space was in sequence, because it had to make sense, because otherwise it couldn't exist because it would be unreasonable. Therefore, but you see what I'm saying is that life on Earth is not really the creator or progenesis of physics. It is rather a response to the universe trying to explain itself. That's why I don't think God exists, is because people always say like, oh, the universe is precariously balanced. The odds of life existing anywhere is like 1 in a trillion or something. But that's precisely it. Quantum mechanically, you have to let life be very nearly impossible to make it possible by the Heisenberg uncertainty principle, meaning the more nearly impossible or improbable it was, the more probable it became by equilibrium. So it became impossible on the moon, therefore it was possible on Earth, and that sort of thing. So those physicists that argue that the scriptures are supported by quantum mechanics are way off. Life in consciousness. Life on Earth is really just an expression of the universe trying to explain itself, almost like a complement. Like a complementary effect of the universe is that it can explain itself subset-wise. And you should always pay attention to this thing, that the subset is important. That's why things are quantized. And here's how I get my results. I pay very deep attention to things like fractals and universal laws. And those are about the only things I really work with, like the three laws of quantum field theory, Newton's laws, Maxwell's equations, the Einstein field equations, which by the way aren't unique and probably aren't even the correct theory, because there's always things like the Weyl curvature tensor and curvature of free space and things like that. So I don't even think Einstein was correct, although it's certainly a very ingenious theory. I would very generally tend to think that Einstein's theory of relativity is not correct. I would prefer a quadratic theory, but we'll see about that. One thing that's interesting about my theories is that I believe the fractals of sex play a role, meaning that the universe evolved in a way almost like people having sex, because it repeats itself over and over again thematically. That's what a fractal dictates. But the universe began as a tetrad, two splitting particles bifurcating, a harmonic oscillator vibrating till it split a hole in space, quantum harmonic oscillator vibrating till it split a hole in space, kind of like penetration in sex, till it split into a bifurcation of particles like children or sperm or something. It's really kind of interesting. The origin of the universe is such that it began as absolute nothing. And they've already proven this. It's called the Hawking-Penrose singularity theorem. But what they mean by nothing is that it really was nothing. But it allows for certain weaknesses in the theory, like there could be a quantum mechanical particle passing through the nothingness. There's a state of nothingness, but there could be a particle passing through from another universe or a previous universe. So there is a weakness in the theory. But I don't really think of that. For a long time, I held that the universe was two universes back to back in an infinite ring, like a Mobius strip, that one universe was the Mobius strip of the other one, meaning that the ingenious thing about the Mobius strip is that I held that the universe was three rings of space Mobius strips and one time Mobius strip. And then I held that the universe was one ring and two space Mobius strips and one time Mobius strip. The ingenious thing about that is you can say that nothing really exists because it turns in on itself. It's only a one-dimensional object in the two-dimensional space. You lose a dimension. So it was my theory and my plan to keep bumping down the dimensionality of the universe, like to keep lowering the dimension of the universe, so that you basically got 0 dimensions from one dimension, then building up to 2 dimensions,